So a tricky part about these problems is often you have to draw your own diagram. So let's read this question here. So it doesn't relate to the cat in the building, it's just a new one. So a dolphin is looking up to the roof, up to the top of the mast of a boat at an angle of 65 degrees. So stop there and visualize what that situation is. You don't have to be a fantastic artist if you don't want to be. I'm not. And I'm think, okay, here's a little dolphin hanging out in the water. Looks pretty terrible. Kind of like a shark, but we'll pretend it's a dolphin. There's the water. And you've got a boat. And it has a mast, so a big tall thing sticking up from it. And the dolphin is looking up at an angle of elevation. And it doesn't say up, but I know an angle of elevation is looking up. So I'm going to go from the ground, and I'm going to look up to the top of the mast. So that measurement there, going from the ground up, is going to be 65 degrees. And if I know my mast is 20 meters tall, well, let's fill that information in. This length over here is 20 meters. And again, I have my right angle triangle in there. So the question is, how many meters does the dolphin have to swim to reach the boat? So that's this distance from the dolphin to the boat. I'm trying to find that side of the triangle. So, to do this, label our sides and think about using trigonometry. We have a right angle triangle, we have one side, and we're using an angle. This is the opposite. We're looking for the adjacent, so we'll end up using tangent, so we can use the TOA as a little trick for ourselves if we want it here. I'm looking for the adjacent, cover it up, so I'm going to have the opposite, which is 20, divided by tangent of the angle, which is 65. And this is going to be equal to 9.33 meters. So you can tell my diagram is clearly not to scale, because I found that x here is supposed to be 9.33 meters. And I believe that. It's a pretty big angle here, so I'd expect it to actually be a shorter side than the 20. So don't worry if your diagram's not to scale. Just make sure you do your calculations correctly there. So my dolphin has to swim 9.33 meters to get to the boat. If we look at a different situation, an albatross is sitting on top of a 10-meter mast on a ship. Okay. So we'll have another ship sitting in the water. We've got a bird with big wings sitting at the top. And he looks out across the ocean, so he's looking out across the ocean, and he sees another bird sitting in the water. And as he sees it, he has to look down at an angle of depression of 35 degrees, so he's looking downwards at 35 degrees. So I'm going to have a right angle triangle in here. And the bits that I need to figure out here is how to get my angles in there. Go back one more step. Our 10-meter mast on the ship, so I'll put that bit of information there. I know that's 10 meters. So again, I can figure out this part of the triangle up here using 90 minus 35, or you can remember with alternate angles that these are two parallel lines, so that this should also be 35 degrees. So either way you want to do that. If you do the other one, 90 minus 35 is going to be 55 here. So this could be a 55-degree angle that you use to solve with, or the 35, but my recommendation is just pick one. If you put both in the diagram, it gets confusing for people. So again, let's figure out what we've got. In this case, we again have our opposite side. And we're asking, what is the distance in the water between the boat and the bird sitting in the water? So we're looking at this distance here, which is the adjacent. So again, we will use TOA. And again, we are looking for the adjacent. So here, my opposite is going to be 10 divided by tangent of 35. 10 divided by tan 35. And you get 14.28 meters. So the bird in the water is 14.28 meters away from the boat. Okay, so those are two more examples. If you want to, you go ahead and, well, the video is going to stop, but you can pause here and try to answer these next two questions on your own that are below about Johnny and a coyote, and we will, well, I'll look at them in the next video as well.